Given question, three spheres A, B and C weighing 300 Newton, 600 Newton and 300 Newton respectively and having diameters 800 mm, 1200 mm and 800 mm respectively are placed in a trench. Determine the reactions developed at contact points P, Q, R and S.
In the given system, we have to find out the reaction forces at the contact point P, Q, R and S. Let us first calculate the angle of inclination of the lines joining the center. So first step, we will join the line A to B. So I will join here. Now this is the line joining the center of the two spheres A and B. Now we have to find out the inclination of this line. So how to find out? So if I draw one vertical line passing through the center A, then here is angle, and this angle we will say alpha, and we have to find out. So how to find out? So we will make here one construction. I will make one horizontal line passing through this center B. And if I extend this vertical line, then here is the point of intersection, and this point of intersection we will say as a x, and here is the perpendicular line. So because this line is horizontal and this line is vertical, so this is the perpendicular, that is 90-degree angle. Now if we observe here, this B to Q distance is nothing but the radius of the sphere B, and radius of sphere B from the given data we will say it is equal to 600. So we will mention here this whole distance, that is equal to 600. And if I join A to P, then AP is nothing but radius of the sphere A. So from the given data it is 400. Now distance A to P is equal to distance X to Q. Now how we can calculate the angle alpha? So if we refer the triangle ABX, so I will highlight this triangle. So from this we can say that sine of alpha is equal to, now this distance is bx divided by this distance is AB. Now how to calculate bx? So we know that bq is 600 and xq is 400. So that is equal to 600 minus 400 divided by. Now if we observe distance AB is the line joining the center. So that is 400 plus 600. That is 600 plus 400. So here is 200 divided by 1000, which is equal to, here 20 is getting cancelled, 1 by 5. So alpha is equal to, calculated value of angle alpha 11.53 degree. Now we will find out the angle of inclination of the line joining the centers B and C. So first we will join these two centers. And now if I draw one horizontal line passing through center B, then here is the angle theta, and that we have to find out. Now we will make here one construction. We will draw one line, incline that line passing through center B as well as center C, which is parallel to this inclined line, which is inclined at 30 degree to the horizontal. So with the help of roller we will take this line parallel to inclined line, and if I draw here line passing through center C, now in the same way we will draw the line passing through center B. So these three lines, that is here is passing through center B, passing through center C, and this inclined line, these three lines are parallel to each other. Now in the same way we will draw perpendicular line to this inclined line passing through center B and C. So these are the point of contact R and S. So normal reaction will be perpendicular to this inclined plane and passing through the point R and S, because these are the point of contact. So we will draw or simply if we join this B and R and C and S, then we will get the perpendicular line. So we will join this. So these are the perpendicular line. So this CS we have to extend. So we have to join. Now if we observe here, here is the angle. So I will give here the point of this intersection, that is X and Y. So this is the formation of the triangle. Now we will consider this angle BCX as a beta. Now I will highlight this. So this triangle BCX, and in this here is the angle beta, and that we have to find out. Now this angle beta is equal to, here is also opposite angle, that is angle CBY. So first we will refer this triangle. So in triangle BCX, how to find out this angle beta? So we can write here sine of beta. Sine of beta is equal to this opposite side. So here this is the opposite side is BX, and this hypotenuse BC, because here this line is parallel to inclined plane and this line is perpendicular to the inclined plane. So here is the right angle. In the same way here is also right angle. So here we have to refer BC. Now how to find BX? So for that we will refer this. Now if we observe this line and the line passing through center C, parallel lines. So distance CS is equal to distance XR, and CS is nothing but the radius of sphere C, and which is equal to 400. So XR is also equal to 400. And what is this BR? BR is the radius with sphere B, and which is equal to 600. So BX I will write BR minus XR divided by BC. So BC is nothing but we have to add two radius of the spheres. So I will write as it is. Now BR is 600 minus XR is 400 divided by BC, 600 plus 400. Now if we observe, here is 200 divided by 1000. So as earlier, because there was the ratio 1 by 5, and therefore beta is equal to, so same angle is there, 11.53 degree. So this beta is 11.53. So we can write here this angle BCX, angle BCX is equal to angle CBY. CBY, because these two lines CX and BY are parallel line, and CB is the common inclined line. So these are the opposite angles. So here is also angle beta. Now if we observe, this line BY is parallel to this inclined line. So if this beta plus theta, so here theta is the angle making by this line BC with horizontal. So if we observe, this horizontal line is parallel to this base horizontal line, and this BY is parallel to this inclined line. So total angle is 30 degree. So we can write here beta plus theta from the diagram. Beta plus theta is equal to 30 degree. So beta is 11.53 plus theta is equal to 30 degree. So we can calculate theta as a 30 minus 11.53. Calculated value of theta is 18.47 degree. Now we will draw the free body diagram. We will draw the same spheres A, B and C, but some distance apart. Now the inclination of this line BC, we know that it is equal to theta. So we will show here the angle of inclination of this BC, that is nothing but theta with the horizontal, and it is 18.47 degree. And the angle of inclination of this AB with the vertical is equal to alpha, and it is equal to 11.53 degree. Now we will observe the given diagram, and there is the point of contact in between sphere A and B, and this point of contact we will give here the number 1, and there is the point of contact in between sphere B and C, and we will give here the number 2. Now we will apply the different reaction forces. So if we observe the sphere A, there is the point of contact P with the vertical wall. So reaction applied on sphere A in the horizontal direction, and it is passing through the center. So we will show here. So we will say here as a RA. So this RA is passing through center and direction is towards the sphere A. There is also point of contact 1. So how to show this reaction? So this reaction is along the line joining the centers A and B, because A and B, sphere A and B is in contact with point 1, and this reaction is also passing through the center, that is A. So we have to show here, and point of contact is 1, so we will say here as a R1. Now in the same way we will move to the sphere B. Now there is the point of contact in between A and B. So R1 we have to show along the same line but in opposite direction. So I will show here R1. Now B and C are also in contact with each other at point 2. So we have to show reaction R2 along the line BC, and direction is towards the sphere B. So here is R2. Now there is the point of contact with inclined plane R. So we have to draw one perpendicular line to the inclined plane passing through the point R. So here is the inclination of 30 degree. So we have to show here the line, that is reaction force R to the base R. So with horizontal line it is having inclination of 30 degrees. So I will redraw this diagram. So because we have to decide the angle of inclination of this reaction. So we know that this horizontal line and this inclined line is having 30 degree angle. Now this reaction R is perpendicular to the inclined line. So if I draw one perpendicular line, then here it is perpendicular to this inclined line. And for this horizontal line, if I draw one vertical line, so this vertical line and horizontal line are also perpendicular to each other. So at the point of intersection, there is the same angle, that is 30 degree. Now if I extend this reaction R to up to the center, and here is the vertical line passing through point B, then here is the same angle, that is equal to 30 degree. So we have to show this. Now at point Q, there is the point of intersection with vertical wall. So reaction we have to show in horizontal direction, and it is passing through the center and direction is towards the sphere B. So here is RQ. Now we will move to the sphere C. So we have to show R2. So along the same line, that is line BC, direction is towards the C. And there at point S, there is also the reaction developed. So in the same way RR, there is the angle with this vertical line is equal to 30 degree. So we have to show here this RS. Now if we extend this RS, then it is also passing through the center. So we will show here. And the angle made this with this vertical, that is equal to 30 degree. Weight of each sphere is mentioned in the question, and we know that this weight component will act in vertically downward direction passing through the center. So weight of sphere A is 300 Newton. So we have to show along the vertical line, and we will mention here 300. Then for this sphere B, it is 600 Newton. So along this vertical line we have to show, and it is equal to 600. And for this sphere C, it is 300 Newton. So along this vertical line we have to show weight, and it is equal to 300 Newton. We will consider this sphere A, and we will resolve this reaction force R1 into two components, one horizontal and second vertical. So the angle made by this vertical component with this inclined line along R1 is same, that is alpha. So how we can decide this? That is its a value R1 cos of alpha. So I will write here R1 cos of alpha, and for this here I will write it is 300, and then for horizontal component we will write R1 sin of alpha. Now we will first take this R1 cos alpha is equal to this 300, because if we observe the vertical force, then R1 cos alpha is having upward direction and this 300 is having downward direction. So when we solve this, because alpha is known 11.53, we get R1 306.18 Newton. Now in the same way we will write R1 sin alpha is equal to RA, because both are the horizontal and in opposite direction. So value of R1 is known, alpha is also known, and therefore RA is equal to 61.19 Newton. So this is the answer, that is the reaction at point A. Now we will move to the sphere B. Now for this sphere B, we will resolve the component R1, R2 as well as RR into horizontal and vertical component. So I will write here. So I will draw this vertical component, and here is horizontal component. Now for this vertical component, that is R1 is making an angle alpha, because in between this vertical line and inclined line same angle is there. So its value is R1 cos of alpha, and for this horizontal line R1 sin of alpha. Now here R2 we will draw horizontal component and vertical component. Now this R2 is making an angle of theta with the horizontal. So here is angle theta. So its value is R2 cos of theta, and for this vertical component R2 sin of theta. Now in the same way we will move for the RR. So its value is, here is horizontal and vertical component. So it is making angle of 30 degree with the vertical. So here is 30 degree. So its value is RR, for the vertical component RR cos of 30, and horizontal RR sin of 30 degree. If we refer this sphere B, then there are unknown R2, then RR and R2. So for these three unknowns, it is impossible to solve this. So we will move to the next sphere C. Now there are three forces which are passing through the same point, that is point C. So we can apply here the Lami's theorem. So we will rearrange these forces. We have to arrange these forces in such a way that they will move in the same direction from this point C. So we will arrange these forces that it will move in the outward direction from the point C. So I will extend this line R2, and we have to arrange this R2. Now this R2 is making an angle theta with the horizontal. So here with reference to the sphere B, here is the angle theta. So if I extend this R2, then this is the horizontal line passing through center C. So here is the same angle theta. So we have to mention here. Then there is 300, which is the weight which is acting in downward direction from the center. And here is RS. So we will extend this RS, and we will draw here that in such a way that it will move in the outward side. The direction is outward side from the center. So here is RS. Now this RS is making an angle 30 degree with the vertical. So here is also vertical line. So we have to show here the 30 degree angle. Now with reference to this diagram, we can apply the Lami's theorem. So Rs divided by sine of angle between R2 and 300, that is sine of 90 plus theta. So theta is known 18.47, which is equal to R2 divided by sine of angle between Rs and 300, that is 180 minus 30, which is equal to 300 divided by sine of angle between Rs and R2. So how to find out that? So if we observe, here is the total angle 90 degree. So 90 minus theta plus 30, because we have to find out this Rs and R2. Now this theta is known. So when we solve this, 300 divided by sine of 90 minus 18.47 plus 30, then we will get 306.18. Now we will move this term to the right hand side and we will calculate Rs. So Rs is 290.40 Newton. So this is the answer, because we have to find out the reaction at point S. We will also calculate R2, because R2 is connected to the sphere B also. So R2 is also equal to sine of 180, that is sine of 150. So sine of 150 is 0.5, therefore R2 is equal to 153.09 Newton. Now we will refer sphere B with summation of all vertical forces is equal to 0. So if we observe, here is R1 cos of alpha. So this R1 cos alpha is in downward direction and we will take here the plus sign. So R1 cos alpha plus R2 sin theta plus 600. Now this RR cos 30 is upward, that is opposite direction. So we will take minus RR cos 30 is equal to 0. Now value of R1 is known, alpha is also known. And then value of R2 is known and theta is also known. And cos of 30, that is 0.86. So when we put all the values, then we will get this, that is 306 into 0.9798 plus 600 plus 153.09 multiplied by 0.3168 minus 0.86 RR is equal to 0. So we will shift this term, that is negative term, to the right hand side. Then we can calculate this RR by transferring this 0.86 to the denominator, and we will get RR is equal to 1095.03 Newton. So this is the answer, because we have to calculate the reaction at contact point R. Now how to find out the reaction at contact point Q, because RQ is the horizontal force. So we have to take summation of all horizontal forces is equal to 0. And we can write here RQ plus R1 sin alpha minus R2 cos theta minus RR sin 30 is equal to 0. And we will put the known values, because RR value is known, then R2 and R1 value is also known. So only one unknown term, that is RQ, and when we calculate we will get 631.6 Newton.